Hi everyone, this is coming to you from Education for All. We are still on trigonometric identities. This is our third video this morning. We are looking at eliminating theta from some functions to give equations relating to only x and y. This is what we are going to look at. We are looking at a problem that says that eliminates theta to give an equation relating x and y. And we have the first one. It says x and theta, x equals sine theta, y equals cos theta. X equals the sine of theta, and you have y equals the cosine of theta. The question says you need to eliminate this theta in order to give the equation in x and y only. You only want us to find a relationship between x and y. Theta is gone. How do you go about that? It's always about sine square x plus cos square x equals to 1, or sine square theta plus cos square theta equals to 1. That's why they're asking us. It's this relationship here they want us to establish here. In that case, if we square all these components, what do we get? If we square x squared, this is going to give us the sine squared of theta. Similarly, you squared y, you're going to get cosine squared of theta. And then you know this relationship. Sine squared theta plus cos squared theta equals to 1. So now we know that sine square theta plus cos square theta, this is 1. We know this relationship. So therefore, we now know that sine square theta, which is x squared here, plus y square theta, which is cos square theta, which is y squared here, we know this is 1. So we have now transformed this relationship, eliminating theta, to only x and y. So this is what they want us to give. There is no theta here, or there is no theta here. There is no cosine function. It's only x and y. So that's what they want us to do. Let's look at the second problem. The second problem says, now x equals sine theta and y equals 2 cos theta. Let me take this off so that we'll have space. X equals sine of theta, y equals 2 cosine of theta. Yeah? 2 cosine of theta, y equals 2 cosine of theta. Yes. That's what the second problem says. So, again, let's square these functions and see what we get, because we are working with squares here, so we always have to square whatever we get. So if you square x, you're going to get sine squared theta. Similarly, if you square y, you're going to get 4 cosine square theta. Right. And we need sine square theta plus cos square theta to get 1. You can't have 4 cos square theta when there is nothing here. So we need to include something here to look like, we need this constant here. Here we have 1, we have 4. We've got to make them the same for this relationship to hold. So which means we need to multiply this by 4. So then, if we have 4x squared, this will give us 4 sine squared theta. And here, we still have y squared equals 4 cos squared theta. So now we have 4 cos squared theta, 4 sin squared theta. We know this is 1. So therefore, we know now that 4 sin squared theta plus 4 cos squared theta is equals 1. We know this relationship, right? But what is 4 sin squared theta? 4 sin squared theta is 4x. So this 4x squared, is 4x squared. Plus, what is 4 cos squared theta? 4 cos squared theta is y squared. It's only y squared. This is y squared. This is 1. Yeah? So this is, you can leave your answer like this. Or, you can simplify if you want. Not necessarily. You can put x squared plus y squared all over 4. This is still equals to 1. If you want, but it's best to leave it here. Yeah? Thank you for watching. Bye-bye.